Hello, this is Roberto and this is the HVAC my channel. Today we're going to be talking about dedicated outside air systems, DOAS Part 3 air distribution configuration. Alright, so let's get into it. So in these videos we've been talking a lot about DOAS because anytime we want to bring to the building outside air, this is a very quick and easy way to accomplish with ASHRAE 62.1. Okay, so let's go in here and find out, like, let's see, I'm going to put this in pink. So now we're talking about number 2. This is the configuration. Okay, so DOAS is in charge of the outside air, and then now we're going to tap directly to the intake of the HVAC unit. Okay, so usually this is because we want to save a space in the building, or ductwork, or sometimes there's no space in the room. For example, in the previous video we were talking about this office or conference room. See, I'm going to put in here conference room, the same thing, conference room. Okay, so for the conference room we had that. I'm gonna put this in here again. So this was ASHRAE. Let's see, ASHRAE, based on ASHRAE or International Mechanical Code, ASHRAE 62.1. So we established that my outside air requirement was 75 CFM. All right. So this 75 CFM is going to be provided by the DOAS system, but this is the main ductwork. See, this is the main outside air ductwork. All right, this is the big ductwork distribution. And then from there, what we're doing is we're tapping a VAV box. The VAV box is actually because this is a conference room, depending on the occupancy, and that's why we put in here a thermostat and CO2 detector. See, thermostat and then CO2, because the CO2 is gonna let you know when this space is occupied or not occupied, and also it's gonna tell you about the CO2 concentration. So that way this VAB box, which is pretty much like this, like a damper in here, controlled, and then it has positions 100% until 30%, right? So when it needs 100%, it's going to be fully opened, and then 30% is the minimum. So in here we have the VAB box, and then through this VAB box, what we're doing is we're injecting 75 CFM directly to the FCU unit. And as you remember, I'm going to put this as an FCU, fan cold unit. This FCU could be horizontal, vertical. It's just like your local HVAC unit. Okay. All right, so this is the confusion when it comes to this system. So again, this is coming, so main OA coming from DOAS, and the DOAS system is on the roof from DOAS, all right? And then, excuse me, so we have the VAB box in here, and then we're tapping directly into FCU. As you can see, we're saving a space actually in here. We're saving a space, and it's actually more practical sometimes when the space is tight. All right. Okay, so the FCU actually, we remember, so from the heat load calculation, this space required 1 ton, right? So this is equal to 1 ton unit. So from the 1 ton unit, we had like in my CFM, based on the cut sheet that we saw in the previous video, it was 370 CFM. That's at maximum speed. So maximum speed tab. All right. Okay. So from 370, we decided we're going to do this 185. But that depends on the designer, right? Because this 370 you can also distribute it, like divided by 4 or divided by, so technically you can have more diffusers, and technically that would be the best way. So I would have one more diffuser right here, or let's see, in this case, let's check that very quick. So okay, so if we do this, for example, 370 CFM, right? So I want to have 4 diffusers divided by 4. This is gonna give me 92.5. See, 92.5 CFM. Okay, so let's see. So in this case, this 92.5, what we can do is actually, I'm gonna put it in here. So we can have 1, 2, right here, 2, 3, 4. So those are going to be my supply diffusers, but I could make this actually as, for example, I would put in here a 90, 90, this would be a 90, and this would be 100. See, so totally it's going to be 100 plus 90 plus 90 plus 90. So I'm going to put in here 100 plus 90 plus 90 plus 90. So how much is that going to be? So I'm going to put in this in here just to make sure. So 100 plus 90 times 3, that's going to be 370. See, this is equal to 370. So it depends on the distribution you want to give to your space. That's what's going to that's going to be the deciding factor. That's why you're the designer, okay? So I'm going to delete this. See, there we go. So what I'm gonna do now is I'm going to make another type of distribution in here. Okay, so in here what we're gonna have is the following. I'm going to add diffusers to the other side. So let's see, like this, for example, and like this, just to make it different, a little bit different than the other video. There we go. All right, so now I'm gonna make like I'm adding 2 other diffusers, and then these are blue. Okay, so these are blue. I'm adding this like this, 1 and 2. There we go, 1 and 2, and then okay, and then after that we need to do the symbol. So this is like this is like this. All right, so now we're gonna put on all of them. Let's see. Okay, so I'm gonna put on in all of them 90, right? So this is going to be 90. So this is going to be 90. This is going to be 90. This is going to be 90. There we go. And this is going to be 100. 100. But usually, typically in the drawings, usually whenever you want to tag it, you're going to put 90 typical of 3. 1, 2, 3. So technically, this is just like some extra knowledge in design that we use. So because space is very important, so because you have to put a lot of annotations in a drawing, for example, ductwork, for example, there's so many annotations that you have to put in there. So there's no space to put 90, 90, 90. Usually what we do is we just put one diffuser like this, and then you put like a leader like this, and then depending on the company, every company has their own standard. See, we put a box, and we would put in here ceiling diffuser number 1, and this would be, for example, 90, and below we're gonna put, for example, typical of 3. See, that's what we put, typical of 3. See, so you only need one. You don't need only like to put in all of them, because this takes a lot of space. So that's why we're going to put typical of 3. So this is just an example. Okay, so the main issue in here, and the reason I'm making this video also, is like I've seen in a lot of projects, in videos also, that they don't really pay so much attention onto this. I'm going to put this in pink because this is very important. Then they don't pay attention on putting the CFM on the return. I've seen projects where they just put return grill 1 and then dash. They just put a dash, right? So the dash is very interesting because they leave it to the contractor. Okay, the contractor is going to size it, the contractor is going to put just a grill, but as designers, I think it's a good idea to put on the CFM sometimes, right? Okay, so let's put on the CFM of the return grill, and that's the part that is very sometimes is confusing. So this return grill, what's the CFM on the return grill? Should it be 370? So technically in this return grill, I'm going to put it on this side, like this, okay, like this return grill. Oh my gosh, so this is going to be white actually. So I'm going to change it to white. All right. So if it's white like this, and then I'm going to put like this, see? We need to size this return grill. That's why we need the CFM. So what is actually the CFM? And this is one of the main reasons I'm making these videos, because I haven't seen a video in YouTube that explains this very well. Okay. So in this case, I have 3 options. So is it going to be 370? Okay. Sorry about that. I'm going to go get it. Yeah, okay. So is this going to be 370? See, 370 CFM? See, it's return air? Maybe. Is it going to be 370 CFM? Not really. So what happens is actually the following. So again, I'm going to go to pink in here. So now that we're injecting directly this 75 CFM to here, see, to the back of the FCU. And then this FCU only can give you 370 CFM, right? So this area, the return grill is gonna give you 370 minus the 70 that's being injected, right? So this leaves me a total of 295 CFM, all right? So technically this is not accurate. So in this case, this should be, the return air should be, I'm gonna put 295 return air, see, return air, and this is the CFM. And just to put things into perspective a little bit more, I'm going to make a little bit of a drawing. So for example, I have this situation in here. So this is the FCU. I'm gonna be consistent with the colors because sometimes also I use these, I use my own videos sometimes to refer to my designs. Okay, so I do this is the FCU. Okay, I'm gonna put in here the FCU, and remember the FCU can be horizontal, vertical. It's called this is the local HVAC unit, right? So I'm gonna put that in there, and then this is the this represents the ductwork right here. I'm gonna put the ductwork right there. There you go. And then this is from the back. All right. So I'm gonna make an arrow right here. But first of all, this is tapping. There you go. Okay. So I'm gonna make an arrow right here. So this is the supply air. So no matter what, this is gonna give me 370 CFM. I'm gonna make this with another color actually. I'm gonna make this with pink, or however color you think that is. So this is 370 CFM, right? This is coming out. All right. So I'm injecting actually in here the following. So based on my ASHRAE 62.1 ventilation calculation for this conference room in particular, I need 75 CFM, right? I'm tapping directly to the back of the FCU. All right. So this should carry, see, this part should carry the difference, which is 295. See, because once you add them up like this, 75 plus 95, I'm gonna go to my calculator on the other side. So 295 plus 75, that's 370. So see, in here I have 370 of mixed air. So this is 370. All right. So how do we call all of this? I'm gonna put in here the following, and in white. So I'm gonna name this as supply air. See, the supply air is being supplied, and then you can distribute this however you want, or it's more convenient for air distribution in your space. Look at this. See? Okay. Now in here, this is the 370. I would call this, I guess, the mixed air, MA, mixed air. All right, and this 295 I would call return air, and this 75 I would call OA, outside air. Well, when it's on the roof, it's conditioned air. Remember, this outside air, which is coming from here, is not coming directly from the outside. It's being treated. Remember when we're talking about DOAS? So this comes from DOAS. So the air is treated, is conditioned. It's not just coming from outside, from the outside. It's not, DOAS is not just a fan on the rooftop. It also has a cooling coil, heating coil, reheating coil. So this outside air is already treated. Okay, so this is coming from DOAS. Return air, this is gonna be to size the grill. I'm gonna put in here size the grill. And I've seen in a lot of projects that they usually ignore this. They just leave it to the contractor. They're gonna put, okay, the submission is coming up, we need to finish this, okay, put it in dash. There you go. So they do it quickly. All right, so this is to size the grill, and this is the mixed air. Okay, mixed air. All right. See, and this concept is very important actually. We need to play psychrometrics in this in so many places. Okay, and this is gonna be the supply air. the supply air. So remember also this is happening everything. I'm gonna put in here in the, this is happening on the rooftop. We can put, no, this is not gonna make sense, but this is usually, I'm gonna put this in the ceiling plenum, okay? So this is all happening in the ceiling plenum, ceiling. So this is in the ceiling plenum, okay, plenum. All right, so the advantages, very quickly, I'm going to mention the advantages is, look at this. You don't need another diffuser in here, like in the other. So in the previous video, we were doing directly to the zone and space. We would have like in here one, right? We would have one, and then we would have the VAV right here, and then we would tap it. So see, ductwork, diffuser, you just tap it directly, and this is going to take care of the mixed air, all right? So overall, this is how it's working, and depending again on the designer, which path you want to take. And remember, this is controlled by the thermostat. See, there you go. Sorry, again, remember, this is, the VAB is also controlled by the thermostat and CO2. This is called demand control ventilation. All right, so I hope you enjoyed this video, and if you did, hit the like button, subscribe, and leave any comments. All right, thank you for watching. The HVAC is my channel. Thank you.